got here a home theater amplifier. It is Denon AVR-X518CI. It appears to be a Chinese version. It says there it's got a simplified Chinese GUI, even though everything on the front is in English. And on the back, you can see that there's writing, Chinese writing. But it is 220 volts, but it's got the Chinese type plug, China plug, which you can tell because it doesn't have the holes for locking it into the socket like that, which you would see in US or Japan plugs. So this thing doesn't work, unfortunately. When you plug it in, nothing happens. And we're going to see if we can work out what's going on here. I notice it's got here a small switch mode. I assume that should be running all of the time, and then when you switch on with the standby button on the front, it should click a relay in down there, I think, to turn on the main transformer and power everything up. I noticed the pinout of this cable which goes over to that power supply board, which says it's got there 5.2 volts on 2 pins, a reset line, 2 grounds, and then a main power. So presumably main power is for the relay. I'm not sure what reset is. Maybe there's a reset generator on the power supply which resets the CPU stuff. There's a STM thing there. Some analog devices, a Panasonic. It supports 4K 60 4444, so uncompressed video. And it looks like that's done with this Panasonic chip. So those are the 4K supporting ones, all wire into that Panasonic chip, and then the other ones go on this analog devices chip. Let's plug it in very briefly, and then I'm going to measure across this capacitor, which should have quite a high voltage DC on it, and that will confirm the input stage, and then we'll investigate a bit further depending on what happens. So I'll plug it in briefly. That should charge up that capacitor. Let's see. Oh yeah, look at that, got 280 volts. So the input rectifier part is working. Now I'm going to wait a little while for that to discharge, or discharge it with something. Perhaps while we're at it, we should try measuring that 5 volts. But presumably the 5 volts should be on all of the time. The ground. Yeah, but because that voltage is staying up there, suggests it's not working at all. I'll just give it a little blip. Yeah, there's nothing there at all. There's a slight click noise I heard. Just wonder if we remove the load, will that change anything? Nope. Okay, so we're going to wait for this to discharge. 300 volts now. And then we'll do a little investigate of the power supply board down there. So something must have gone wrong with it. It might be easier that we just bodge in some other 5 volt power supply and power up this electronics. But we need to work out what the reset pin does. Presumably a reset generator is on that, which we'll be able to discover. The other things we can look at in the meantime, there's another power supply board there, which looks like it comes out of the main transformer, and then it's got some fuses, little brown things, and then there's a rectifier, and then there's a bunch of regulators on the bottom, and then that comes over here. And what does that say? Plus minus 12? Yeah, plus minus 12 volts, and something else that I can't read from here. So that's the analog power supply for all this business. And then there's a cable coming off the front to the front there. So that will be the filament voltages and the drive voltage for the VFD. And then there's this main winding coming out of the transformer. There's a relay there, rectifier, and then there's big capacitors down there. So that will be all of the power for the amplifiers, which are in here. It looks like it's 5 channels with those speaker outputs there. It's just got a pre-out for the sub connection, so you've got to put a separately powered subwoofer on if you want to use that. RCA plugs for the sub output seem to be bent over a bit. I wonder if somebody's been rough with that. It seems like a pretty low budget unit because there's not very many inputs and things, not like some of the other units I've seen which have covered in plugs. But you do get a USB socket on the front and a setup mic. I don't have that though. I don't have the remote either, and it's missing this knob. Alright, we'll get this power supply board out and have a look at it. It has been discharged. It's recovered back to 2 volts. And the light is reflecting on it. There you go, so it's safe now. I used this resistor and some clip leads. So we can take that board out. There are some screws at the back that are holding it. Cut a cable tie there so we can get that out of the way. Oh, there's another thing we have to undo from the bottom there. So you use different plugs there, so that's good, so we're not going to mess that up. We'll get this stuff out of the way for now. Now here is power supply. It's got some kind of chip there, that's the diode. That seems to be the control IC. It's got feedback optocoupler. Not a lot else going on. Ah yes, look at that. That must be a reset generator going to the pin 3, which I think is reset. Yes, pin 3, reset. So there's some sort of reset generator on there. Weird. And then there's a transistor there for driving the coil of the relay. Positive, so that's negative. So yeah, you pull that high to turn on the relay to turn on the main power, and it's just those capacitors are in parallel, and some clamp using a whole bunch of Zeners. You can see them all in series there. A whole bunch of series Zeners back to the positive rail. So it'll be a flyback clamp. So I think what we should try to do is inject some voltage into the rail and see if it rises up, just to see if there's anything shorted out on there. Got a power supply here. We'll just set this down to 4 volts ish. Set the current limit way down to a small amount, and we'll attach that and then power it up. I'll make sure it's around the right way. I don't really want to power it up backwards. And we'll turn this on. Yeah, it seems to work, doesn't it? We bring that up to 5 volts. There doesn't appear to be anything short circuit. I wonder if we can look at the reset chip. I wonder if that will work on this multimeter. Let's see. It says 0.7. If we turn it on, it goes to 0. If we put the voltage out of range, oh, we have to wait for it to discharge. It goes to 1.2, does that? Maybe it probably needs a pull-up, doesn't it? On the reset output line. So it might be an open collector thing. So it's floating to that voltage. That's what I would assume there. Since it sets at 0 when the voltage rail is out of range. So it'll be pulling the reset line, and then it releases a short time after it reaches 5 volts. Okay, yeah, that's pretty simple. So that probably means that we can try powering up the amplifier by injecting our own 5 volts into there. But as for why it's not working, yeah, that's the question, isn't it? All of the everything is done inside this chip here. So perhaps we should look that up and see if it reveals some secrets, and then we can try measuring various diodes and things. It doesn't appear to have any evidence of smoke escaping, but you never know. We'll take a look at it. I'm going to attach a piece of wire across the 5 volts capacitors so that we can try injecting 5 volts into this power supply and see if the amplifier will start up, so that we can see if there are any other problems. Perhaps there was a reason why the switch mode doesn't work. Perhaps something was shorting it out or giving it a hard time in some way. But because this has dangerous voltages on it, I want to have it mounted in the amplifier when powering it up to test. But can't reach, so we've got to solder these wires on to allow it to be powered up while it's installed in place. So we'll just tin these. And then we'll solder it on with the red line to positive. Seems sensible, doesn't it? There's a space for an extra capacitor there, which isn't installed, so perhaps we'll solder it onto that. Did notice this hasn't been turned on for several days, and that main DC input capacitor still has 40 volts on it. So you got to be pretty careful. So when the switch mode doesn't run, there's nothing to discharge the voltage. This seems to be around the right way. So reassemble that, and then we can inject some voltage from a little power supply, and then we'll see what happens. They used a different connector for each plug, so that helps you not connect it up around the wrong way, because I don't really want that. Fairly loose, just need to hold it in position so that nothing shorts out. Now we'll connect that and we'll do a smoke test, see if any of the smoke escapes. Got a small power supply here, we'll set this up to 5 volts. I think it is already set to 5 volts. Yep, already set to 5 volts. So connect that up to these wires, hope that they don't touch together. And then we'll turn this on at the same time as plugging this in. And we'll see what it does, because it should, the 5 volts should power up this electronics, and then it should pull in the relay in the corner there, which should power up this main transformer. Oh, that seems to be just switching on and off. Okay, so it switches the main transformer on and off continuously. I wonder, is that action that killed that power supply maybe? Perhaps we should check the reset signal that we saw coming out of there from the power supply to see if that's causing this system to reboot. I need to get an oscilloscope set up for that. We have a look at the reset line. It's going up and down. If we look at the 5 volt line, there's a very small glitch on there. So it makes me wonder, is it possible the capacitors on the output of that 5 volt switch mode have dried out, and that's meaning that all the energy drawn by pulling in that relay sags the 5 volts just enough to trip the reset generator, which is right near where the relays are, and then the microcontroller powers off and it recycles again. So I'm going to have a look at those capacitors and we'll see what condition they are in, or perhaps we'll just try tacking some capacitors, new capacitors across it. I'll see. I'll take one out if I can get it out easily and try and measure it. Took out one of the caps from there. Let's see how it measures. You can get it into this thing. It's a pretty big cap. Is it 5,000 something microfarads? And it still measures pretty good. 5,600. But it measures 6,000. We'll just see. That meter might be a bit dodgy. We'll try this one. And then we might try some better caps anyway. Yeah, it comes up as 7,000. So yeah. I'll have to see what kind of capacitors I've got that we can put in its place as a test. I found some capacitors. This 16 volt 2200 microfarad, which is not that close to the one we're looking for, which is 5600 microfarad. But I put 2 of those in parallel since there was an extra footprint unused, and that's now down there, and soldered this wire on to across the capacitor so we can inject 5 volts into there. I did already try this and I worked out what the problem was with powering this up externally. Is that, as it says there, it's actually 5.2 volts that it needs, so that's been wound up now to 5.2 volts. And if we put this on, now push the standby power button on the front. comes on, drawing 8 watts-ish over an amp, nearly 2 amps. Yeah, it's pretty grunty. I just gotta watch out because there's live stuff there. So it seems to turn on all right. The screen's lit up. It's a bit hard to see from this angle, but see there, volume and presumably input selection. Yeah, all that good stuff can be chosen. So what I want to do now, what we should do, is see what is this simplified Chinese UI all about that it talks about. So let's, got an HDMI signal here, let's connect that up. I think that's the output on the end there. Just check that. Yeah, the output is that end one. There's a bit of ground loops going on. Let's see, does that do anything? Would I have to click a button? A display button maybe? No, there's not many buttons on this. So maybe that UI it's talking about isn't actually the HDMI UI. Presumably what we've got there is, says there's nothing happening. Maybe what we need is an HDMI input connected into it for it to recognize that. Maybe it's not actually a user interface that works unless... Oh, I've got another thing here. Let's try and find... Goes to my little microscope camera. Problem is I've run out of places to plug stuff in. So little microscope camera, let's plug that into one of these inputs. There's quite a few inputs. Into Blu-ray maybe? Blu-ray sound like a good thing. Blu-ray. And then we'll turn on the camera by plugging in its power cord. Still no good. That's a bit disappointing. Maybe there's more issues with this amplifier than we thought. Okay, let's try putting it in the... Oh, there's 2 Blu-ray inputs. Oh, one's a 4K and the other one's not. Let's try it on the media player input. Doesn't do anything. Maybe you need the remote. Surely you don't need the remote. Try directly to a monitor, maybe, instead of into the splitter and the capture. Maybe we'll try cable satellite input. Okay. Yeah, I don't know. Let's try a few more things and then get back to you if anything interesting happens. Alright, worked out what the problem is. Silly thing. I had the other end of this HDMI cable was connected to an output, not to an input. So obviously that's why it's not going to work. So let's turn this back on and see if anything happens. That's still connected. And it still doesn't seem to be doing anything. Okay. That's a bit boring, isn't it? Still doesn't show anything out the output. It does have HDMI lit up on the screen. Okay, I wonder if it can recognize a USB drive, the USB port on the front. And it seems to think it's playing. Nothing's coming out. Maybe there's more issues going on. It's really bizarre. It looks like without a remote there's really nothing you can control. Alright, I'll get back to you if something else changes. Unfortunately it might be cooked. That chip there is burning hot, can't put your fingers on it. These other ones seem okay. So I'm wondering if maybe the power supply, when it burned out, that 5-volt switch mode thing, maybe there was a voltage spike or over voltage on the 5-volt rail which has managed to burn out that and possibly other things, which is a bit disappointing. That would explain why there's no output coming off the HDMI stuff, because that's done with this chip here. It's a Panasonic something or other. Yeah, there's a Panasonic thing, and there's an analog devices, and there's ST microcontroller thing. Alright, so that might be it for this amplifier. Quite a long time later, I thought I'll give this thing a final check before it gets scrapped, because if that chip's dead, then can't really do much with it. And I also was wondering, maybe that chip got killed by something, maybe something happened to something that was connected through the HDMI, burnt it out. static discharge or some other problem, and then the load of this chip cooking itself could have killed the 5-volt power supply. That's possibly more likely than the what I'd said before, which was the 5 volts dying and damaging the chip. Anyway, let's just turn it on again just for fun. I've got the 5 volts supplied externally. It's very sensitive. Got to put the voltage up to nearly 6 volts. Possibly multiple problems there. Anyway, it's turned on. That thing will start cooking itself. You hear the relays. Look at that. It's just rising in temperature. What else is interesting is if you look, it looks like the chip is there, but what that's doing is it's seeing the reflection of the heat off the metal back panel. The chip is there, so that's why you got to be very careful about reflective surfaces or non-matte surfaces. It will look like you're looking at the thing, but actually it's a reflection, so be careful. But anyway, we can see this camera, which is faulty, it reads temperatures lower than what they are for when it's above about 50, and that's showing about 80 degrees, so it's probably more than that. And yeah, it definitely feels warm, which I don't think how it's supposed to be. I think it's more likely to be, should be something like this, where it's around 40, or that CPU chip there, the ST, which barely shows anything. Then that thing's Cirrus Logic chip, 30, another Cirrus Logic chip, 36. So yes, you get the idea that that is cooked. I was wondering, can we measure a power supply to it? What if its power supply has burned out and that's the reason why it's not working? So we can check this. So that's 5 volts coming in there. So that means my power supply is quite off. Oh, there's a voltage drop. It's drawing 1.5 amps. So, okay, so I think the meter on the power supply, the wire is too short, I can't show you, is a little bit, because it's supposed to be a 5.2 volt power supply. It's still low. Yeah, that would be why I had a bit of trouble starting. But anyway, I thought these here, the capacitors, probably the voltage rails for the chip. 1.1, 3.2, 3.2. Well, those will seem believable, and they're not 5 volts, so it suggests that it's not that the regulators supplying the chip have stopped working, and they're not overheating, which is surprising because that's probably putting quite a lot of extra load on it. So there you go, that's the end of that. This amplifier is no good. I did see, it's not the end, is it? You can buy that chip on AliExpress or eBay, but yeah, I don't really feel like trying to replace that, because I'm pretty sure it's got a power pad on the bottom of it, and yeah, trying to get that off is quite a lot of effort will be required. Let's just have a look at the bottom. I've taken the fuse out there so this wouldn't have charged up, because yeah, that was quite a risk there, a dangerous risk having that capacitor charged up to 300 and something volts and not able to discharge because the power supply running from it is blown and doesn't draw any current anymore. So just be very careful about that stuff. It's unplugged now, and we should just prove that anyway to make sure. It's got 24 volts on it, which would just be some of the like diode pump up effect of having the neutral still attached. Well, you don't know because that's non-polarized, so it could have had the phase attached to the leg that is not broken by the fuse, and then just through capacitive coupling to other things, and probably some, that filter there, filter capacitor, it would have rectified a bit of the mains voltage, and that's why that sits at 24 volts now. A very high impedance voltage doubler type thing going on. Anyway, oh yeah, there's a bit of stuff on the bottom there. There's more on that one. But yes, you can see there's a bunch of wires there in the center of the chip. So it has got a thermal pad on it, and that will make it quite difficult to remove. This one probably does as well, maybe, or that might just be power planes. Yeah, so there we have it. That's Denon AVR-X518CI power amp in a sad state. And I don't know if it's worth repairing, because anyway, we didn't even know if it has an English user interface since it says that it's Chinese on the front. So I don't know if it was, then it wouldn't be difficult to use. That's the radio tuner there. I think you use by I2C, something like that. SDIO and SCLK, probably I2C. Fully integrated, it's just the left and right audio come out of it. Yeah, that's probably a special radio chip. Don't know if there's more, we can't really see the other side. Okay, and main board down there, pretty stingy on the caps. Main caps, and then there's the amplifier stuff. This bottom board, pretty much just an amplifier, there's not really much else going on in here. And the speaker configuration, although that's pretty basic as well. I think that's just de-thumping relays or muting relays. It's just the audio signals on there, and then the relay signals on here. Back relay, HP relay, front relay. Oh, there's more over here. Some thermal detectors, DC protect, ASO detect, amp sig detect. Okay, great. That's the amplifier. That's business. It's got weird this board, piece of circuit board to hold the wires, and that's screwed into the top. It's very dusty in here. Oh, it's only one piece of stuff. One. So that screw does nothing then? Just locates it, I guess. Weird. Is that the USB? Probably. Oh no, there's a thing on the front. Let's take the front off and have a look. There's a thing on the front. Yeah, that's good. Okay, let's take the front off. Anyway, that's the other one of those. Oh, they're different. They're not even the same thing. That's a bit whatever. Yeah, I think it's the Bluetooth thing down the front there. I wonder if that could work as a standalone Bluetooth emitter. Although I don't really know why you'd want it, but Bluetooth audio is a bit cheesy and dated, isn't it? I'd rather just plug into the earphone socket on your phone to get the audio onto something. Something that just works. Okay, will that come off? Will come off. Great. There were screws under there. Now that's the output from the transformer, which will be the different voltages for the VFD. Then there's the earphone socket with the detect. I see, it's got a detect line which goes into the CPU, so that must turn these relays off automatically when you plug the earphones in. And that's what I saw, look at that. It's some kind of WIN bond, and there's the Bluetooth. So that's got the USB on it, the setup mic. Let's take that piece off and have a look at it. Now, unfortunately, we've got to unplug that wire to get to the screw that holds that board, but that's okay. Oh, maybe we didn't have to. It's just a matter of lifting that up, is it? Oh, it's got tape holding it down as well. There's a pinout written on the bottom of this Bluetooth thing. It's got RxTX, CTS, RTS, VCC, ground, SCL, SDA, Bluetooth adapter card, made in Korea. I don't know, is that a whole like Bluetooth audio thing? Don't know. Don't know what that will be. Whether it can cope on its own or not. So that's a BX8804. Don't know what that is. Oh, and there's a Burr Brown PCM thing. I wonder if that's a DAC. Probably, and then there's the audio output from this stuff. And there's all sorts of pins. There's a pin out given there. It's got minus 12 volts, plus 12 volts. Mic detect, because it's got the setup microphone connector there. And USB enable, USB DAC mute. Oh, this is 9. It's PX reset. It's got USB transmit receive, USB power, USB 3.3, digital ground, then some other things, 5 volts I guess, digital 5 volts. Then this other connector, can't see easily what that pinout is. Oh no, it's just written in a different place. That's here. It's got mic, sig, A ground, USB / Bluetooth, so it must be a selection. And then presumably it's the audio. There's another, oh no, it's not a selection, it's USB Bluetooth left, USB Bluetooth right, that's the audio. And then another 5 volt analog. So I guess you have to talk to the USB with this transmit and receive line to get it to do the thing, to get it to choose songs to play off your USB drive, I guess. Because yeah, you'd have to navigate a USB device. I don't know about Bluetooth, whether you can just power this up, pair it, and then use it. It didn't have any Bluetooth specific pins. Interesting. So that's a thing that does stuff. There's a JTAG port there. Say there, TDI, TCK, TMS, TDO, all that good stuff. Oh, it says ARM on it. I guess it's a special ARM thing for doing audio stuff. Okay, let's just take these other bits out. Maybe a nut to unscrew there. Function selector, rotary encoder, bi-color LED. Look, it tells you about it. Common cathode. Yes, yeah, because you have trouble getting those around the right way, because if you put it around the wrong way, then it's not going to show the right color. Oh, look at that, it's a character display. Display with good character. So you can, yeah, it's not 7 segments or 14 segments. So that's something that has a, well, it's got some form of intelligence in it, because it only has that many pins, you see? It's got the like lead frame thing inside the display, but legs only come off of a couple of them. There's still got the filament, and then there's probably some other voltage driving things there. And then there'll be some data connection. Can we read what it says? Yeah, FL data clock, CE reset, CPU power. Yeah, so I guess it's just a serial shift register thing. That's exciting. That means there's potential of using that display for something. Have some scrolling text on it. If you wanted to fiddle around working out the protocol, making drivers and things. Alright, that's interesting. Quite interesting there. Display that you could do something with if you wanted to. Probably would put this thing back together and power it up and then probe those with a logic analyzer and see what's going on. Be the cheap way of working out what the deal is. Yeah, so this thing's getting scrapped. That's what's happening right now. The aluminium out for higher value scrap. There's steel. Great. That's a look inside an amplifier. An attempt to fix it that is probably not worth it, because you'd have to replace a complicated chip. And then a look at some of the other bits and pieces that are in here. Great.